All right, welcome back. Welcome back, Algebra 2. Let's go ahead and use our newfound knowledge to kind of identify which is a polynomial and which is not. So determine whether the following are polynomial functions. If they are, then state the degree, type, and leading coefficient. So let's look at this first one. Okay, so the first thing we always want to make sure is that our function is written in standard form. Okay, so make sure our exponents are descending. So if I start with 4, that means I want to make sure that every single term afterwards has an exponent that is smaller than 4. So here's 4, 2, and then this is technically 0, right? X to the 0. So we're good. This is good in that regard. We checked, we're good in the exponent department. Now we have to make sure all our coefficients are real numbers. And it looks like they are. The only time that will ever be broken is if we have an imaginary number. We hardly will ever see that, so we don't have to worry about that. The only thing we have to worry about is making sure it's in descending order, and then our exponents are all whole numbers. So then it definitely is a polynomial. So yes, right. This is a polynomial because all exponents are whole numbers. And then I can go ahead and rewrite in standard form if I want. And then all my coefficients are real numbers. So now state the degree. Degree is the highest power, so it's 4. Degree equals 4. So that means it's a quartic based on the table we made above. And our leading coefficient is 1. Okay, not too bad. Next one. All right, the only thing we have to check is to make sure all our exponents are positive whole numbers. Yes, here's a squared, so that's good. Here's a first power, that's good. And then here's a constant. So yes, this is also a polynomial. Now let's rewrite it in standard form though. So f of x is equal to pi x squared, right? Because that's the biggest exponent we see here, plus 7x minus rad 3. So then what's the degree? 2. So it's a quadratic. Oops, sorry. And the leading coefficient is pi, right? That's the coefficient on the biggest exponent term. Okay, 2 more. All right, what do we check for polynomials? We make sure all the exponents are whole numbers, positive. Looks like this one is not a polynomial because we have this -1 as an exponent, right? So that's technically equal to 3 divided by x, right? Remember from our section 5.1 how to rewrite terms with negative exponents. So that means that this is not a polynomial. And the reason why is because of that negative exponent. Last one, x plus 2 to the x to the power of x minus 0.6 x to the 5th. So these two terms are good. There's an issue with this term, right? Our exponents need to be whole numbers, right? Now, x is allowed to be a whole number, but actually x is allowed to be more than just whole numbers. And on top of that, the exponent is changing. The exponent's allowed to change. And when that's the case, it is not a polynomial, right? So we can't have a variable in our exponent either. It has to specifically be a whole number. It cannot be a variable either. Okay. So now let's just get some practice in with evaluation. We're used to this, right? We've done this before, but now let's just do it with higher degree terms, okay? So let's start with the first one. When we evaluate, remember, that means take our x value. So if we want to evaluate this function at x equals -2, we plug -2 in for all the x's. So f of -2, that's equal to -2 to the 4th plus 2 to the negative times 2 to the plus 2 times negative 2 to the third power. Sorry about that. Plus 3 times negative 2 to the second power minus 7. Okay, so I would not advise you to put this all on your calculator, right, at once. Go ahead and calculate each piece first. Negative 2 to the fourth power, we know 2 to the fourth power is 16, and negative to the fourth, that's going to still be a positive. Negative times negative is positive, times the negative is negative, times the one more negative is positive, okay? So plus negative 2 cubed, well, 2 cubed is 8, negative cubed, that's going to be negative 8, because the negative times the negative is the positive, but then times the negative is negative. Negative 2 squared, that is going to be 4, times 3 is 12, minus 7. My apologies, in this term, we still have to do this 2 out in front, right? So 16 plus 2 times negative 8, that's negative 16, plus 12 minus 7. 16 plus negative 16, that's 0, plus 12 minus 7, that's going to be equal to 5. So f of negative 2 equals 5. Awesome. All right, one more example of these, or of this. So same idea. Now let's plug in 4 this time. We have f of 4 is equal to negative 4 cubed minus 5 times 4 squared plus 6 times 4 plus 1. Okay, 4 cubed, what's 4 cubed? That's 64, and then attach a negative, negative 64, minus 4 times 4 is 16, times 5, that's 80, plus 24, plus 1. And then you can put this in your calculator if you'd like. That's going to end up giving you negative 119. I'm going to double check really quick just to make sure that I didn't press any wrong buttons, because this calculator, the buttons tend to be a little annoying. Okay, yeah, we're good. So f of 4 is equal to 119. All right, so hopefully that should be a review for you. Meet me in the next video where we'll talk about the last topic for this section, which is end behavior. All right, see you there.